Hello and welcome. In today's lesson, we're going to continue our discussion on solving quadratic equations. First, I'd like to recall the zero factor property. If you remember from our previous lesson, the zero factor property is if the product of two or more factors is zero, then one of the two factors must be zero. Or, in other words, if we're multiplying two things and the product of those two things is zero, then one of them must be zero. For example, if you've got x times y, and that product equals 0, then either x is going to equal 0, or y is equal to 0. It is possible that even both of them are equal to 0. Now, our method of solving quadratic equations is as follows. First, we're going to set the polynomial equal to 0, and then factor the polynomial completely. Then, after we've factored, we use the zero factor property to solve each individual factor for x. To show this, let's solve the following equations. Step 1, I make sure that the polynomial is equal to 0. Here on the left, it is equal to 0, so I proceed to the next step, where I factor the polynomial. Since this is a trinomial, I use my diamond. On top I have an 8, on bottom I have a 6, and my two numbers are going to be positive 4 and positive 2. So I rewrite my positive 6x as positive 4x plus 2x. I still have the x squared in front and the plus 8 behind. Now that I have four terms, I may factor by grouping. So I split this down the middle and take out the x on the left, leaving me with x plus 4. And on the right, I take out a positive 2, leaving me with x plus 4. This still all is equal to 0. On the left, I take out the x plus 4. And when I factor out the x plus 4, I'm left with x plus 2 in the second set of parentheses. Now from here, I apply the zero factor property. The zero factor property says if you're multiplying two things together, so here I'm multiplying an x plus 4 by an x plus 2, since I'm multiplying those two things and the product, or what they equal, is 0, then either one or both of those two things must be 0. So I'm going to take my first factor, x plus 4, and set that equal to 0. If that first factor is equal to 0, if this whole thing equals 0, then when I multiply by the other factor, my product will be 0. Similarly, with the other factor, x plus 2. If this factor equals 0, then when I multiply by the other factor of x plus 4, the product will be 0. Solving both, I find that from the left, I may have an x value of negative 4, or from the right, I may have an x value of negative 2. So your two solutions for this polynomial are x equals negative 4 or x equals negative 2. On the right, step 1 in factoring is always to factor out the greatest common factor. Here I see I can take out a 2, but since my leading coefficient is negative, I must take out that negative 2. Now, since I took out the negative, my x squared has a positive coefficient. From here, the only way I can factor is by applying the difference of squares. Since x squared is a perfect square and 16 can be written as 4 squared, it is also a perfect square. And since those perfect squares are being subtracted, I have the difference of squares. So I'm going to rewrite this as x squared minus 4 squared. Since I have the difference of two perfect squares, I may factor this into x plus 4 and x minus 4. That negative 2 is still on the front, and the product is still 0. Now for every factor that has an x, I will take that factor and set it equal to 0. This negative 2 on the front, since there is no x there, we can just ignore it. So I'm going to take my factor of x plus 4 and set it equal to 0. Or my x minus 4 may equal 0. When I solve on the left, I find that x can equal negative 4. Or when I solve on the right, I find that x can equal positive 4. So your two solutions for this equation are x equals negative 4 or x equals positive 4. Let's go ahead and recap for a moment the 3 steps to solving quadratic equations. Step 1. We always must ensure that the equation is set equal to 0. So in this first polynomial, there is a 0 on the right-hand side, so step 1 is done. Step 2, I then factor the polynomial completely. Since there are 3 terms in this polynomial, I'm going to use my diamond method. 9 on top, negative 6 on bottom. My 2 factors are negative 3 and negative 3. So I rewrite my negative 6m as negative 3m minus 3m. I still have an m squared in front, a plus 9 behind, and it still is equal to 0. Now I split my polynomial down the middle and take out the greatest common factor of m from the left, leaving me with m minus 3. And from the right, I factor out a negative 3, leaving me with m minus 3. Dividing that positive 9 by a negative 3 leaves me with negative 3. Factoring further, I factor out m minus 3, which leaves me with, in my second parentheses, m minus 3. Step 3. I apply the zero factor property. I'm multiplying 2 factors and the product is 0, so either one or both of those factors must be equal to 0. So I'm going to take each factor, set it equal to 0, and solve. However, since these factors are the same, there's no use in solving both of these equations. Once you have solved one of them, then you have solved both of them. So here on the left, when I add 3 to both sides, I find that m equals 3, which will also be the case in the second equation. So my only solution for this polynomial is that m will equal 3. Go ahead and take a moment to pause the video and try the next 3 on your own. From the first, you should have factored out a greatest common factor of 3 before factoring the trinomial. Factoring the trinomial, I obtained x minus 3 and x plus 1. Setting each of those factors equal to 0, I obtained final solutions of x equals 3 or x equals negative 1. On the bottom left, I obtained x equals negative 3 or x equals negative 1. And last, m equals 2 or m equals 3. On this next slide, we're going to proceed through those 3 steps again. Step 1, we ensure that the equation is equal to 0. Now in this first polynomial, you should see it does not equal 0, instead it equals 3. So I need to get rid of that 3 and make it a 0. In order to do that, I'm going to subtract 3 from the right, subtract 3 from the constant term on the left. Now on the right, once I subtract 3, I end up with 0. And on the left, I'm subtracting 3 from that constant term of negative 6, which becomes negative 9. Everything else stays the same. I still have a negative 3x and a positive 2x squared in front. Now I proceed as we did on the last slide. Factor the polynomial completely. Since this is a trinomial, I use my diamond method. First, check and make sure that there is no greatest common factor you can factor out. Since there is not, I go straight to my diamond. Multiplying the front and the last, 2 times negative 9 is negative 18, and that goes on top. On bottom, I have a negative 3. My 2 numbers are a negative 6 and a positive 3. So I rewrite my negative 3x as negative 6x plus 3x. I still have the 2x squared in front and the minus 9 behind. Splitting this down the middle, I take out a 2x from the left, leaving me with x minus 3. And from the right, I take out a positive 3, leaving me with x minus 3. Still equal to 0. Factoring out that x minus 3, I'm left with a second factor of 2x plus 3. Now we're on to step 3 in our factoring process. I'm going to apply the zero factor property. My first factor of x minus 3 I will set equal to 0. Or I may also have a solution where 2x plus 3, or that second factor, is equal to 0. Solving the left, I find that x may equal 3. Or, on the right, I'm going to first subtract 3, and then I'll divide by that positive 2 in front of my x to get x equals negative 3 over 2. So my 2 solutions are x equals 3 or x equals negative 3 halves. On the right, I do not have a 0 on one side of my equation, so I must subtract 2 from both sides. Subtracting 2 from the right leaves me with a 0, and on the left I make sure to subtract from that constant term, leaving me with a positive 2. I still have a positive 6n and a positive 4n squared in front. Now I proceed to factor my polynomial. Step 1 is to factor out any greatest common factor. I see a greatest common factor of 2, so I factor out that 2, leaving me with 2n squared plus 3n plus 1 equals 0. And now I apply my diamond on the trinomial inside those parentheses. In my diamond, I have a 2 on top and a 3 on the bottom. My two numbers are a positive 2 and a positive 1. So I rewrite my positive 3n as positive 2n plus 1n. I still have a 2n squared in front and a plus 1 behind. Factoring out the greatest common factor on the left, I have a 2n, leaving me with n plus 1. On the right, the only thing I can factor out is a positive 1, leaving me with n plus 1. I factor out that n plus 1 and am left with 2n plus 1 in my second parentheses. Don't forget this is all equal to 0, and there is that coefficient of 2 on the front. Now step 3, since I've factored completely, I apply the zero factor property. So from my two factors, I see either n plus 1 may equal 0, or my 2n plus 1 may equal 0. Solving the first, I see n may equal negative 1. And from the second, I'll first subtract 1 to get 2n equals negative 1, and divide by 2 to get n equals negative 1/2. So our two solutions for this quadratic are that n may equal negative 1 or n may equal negative 1/2. Go ahead and take a moment to pause the video and try the next two on your own. Your first solution should be r equals 1/2 or r equals 3. And second, on the bottom right, you should have a equals 3/2 or a equals negative 2. Last, we are going to discuss what if there's not a constant term on the right, but instead you have a term with a variable. We're going to still need to make sure that we follow step 1 and obtain a 0 on one side of the polynomial, but we might have to rearrange our terms just a little bit. Keep in mind that you always want your quadratic term or your squared term to be positive. So when you're moving terms around, make sure that you keep your squared term positive. Since my squared term is already positive, I'm going to add the 5k from the right and move it to the left. Now remember that you always want your exponents to go in descending order. So first I'll write my 2k squared, and then I will write my positive 5k before I write my positive 2. And all this equals 0. Now from here we factor completely and use the zero factor property. Since it's a trinomial, I'll use my diamond method. I have a 4 on top and a 5 on the bottom. My two numbers are positive 4 and positive 1. Rewriting my 5 as positive 4k and positive 1k. I still have a 2k squared in front and a plus 2 behind. Factoring, I take out a 2k from the left, leaving me with k plus 2. And on the right, I can only take out a positive 1, leaving me with k plus 2. All this still equals 0. Now I have a greatest common factor of k plus 2 that I may factor out, leaving me with 2k plus 1. Applying my zero factor property, I see k plus 2 may equal 0, or my other factor of 2k plus 1 may equal 0. Solving each of these, I find that k equals negative 2, or k equals negative 1/2. You can solve those two equations on your own. On the right, notice that my quadratic term is already positive, so I'm going to move everything from the left over to the right, keeping that quadratic positive. First, I subtract my 4r, and then I'm going to subtract my 3. Now I have a 0 on the left equaling 4r squared minus 4r minus 3. Go ahead and pause the video and finish this one and the next two on your own. From the first, you should have r equals negative 1 or r equals 3/2. Second, you should have p equals negative 3/2 or 1. And last, remember you should have factored out a GCF of 2 before factoring your trinomial, leaving you with a as 1/2 or 1. Thank you so much for watching. I hope you enjoy the rest of your day.